use of natural pozzolanic material as special replacement ordinary Portland cement OPC in concrete. This presentation will consist 5 elements, which are introduction, material, experimental tests, results and analysis, and last but not least, conclusions. So, what is actually the fly ash? Fly ash is a pozzolanic material which is an industrial waste that is produced from the burning of coal in thermal power plant. Fly ash is a pozzolanic material that containing aluminous and siliceous material that forms cements in the presence of water. Fly ash forms a compound similar to cement when existing of lime and water. According to Eaglehead 1995 mentions, pozzolana is a siliceous and aluminous material that it itself possesses little to no cementitious value. From Hall 2017 report that using fly ash in concrete mix as replacement of cement increase its compressive strength. From Malhotra 2000 state that fly ash as one of the potential material in reducing the use of cement in construction, as it possesses similar binding ability as of cement while containing little to no hazardous chemical substance, making it a more sustainable and environmentally friendly alternative. By OC 2012 state pozzolana by mentioning the replacement of cement with pozzolana significantly increase the strength of concrete, while at the same time decrease the workability of concrete, which leads to better vibration resistance, giving it an alternative usage in construction industry such as road making. Therefore, from the collection of studies, fly ash as pozzolana presents itself as an attractive partial replacement to Portland cement due to leaving lesser environmental footprint while potentially enhance structural quality of concrete. Using large amount of cement will increase dust around the construction site and contribute to environmental pollution and affect health. According to Chindra Parasit 2004, fly ash is more environmentally friendly than typical cement because it does not release any dangerous chemical substance, and thus opening the door to partially replace cement in construction projects. Therefore, this study was conducted to investigate the use of fly ash as partial replacement of cement in concrete as a means of producing more environmental friendly concrete. The cement used was ordinary Portland cement in compliance to BS 12 1996, while the pozzolanic material used was fly ash with conformance with ASTM C618. The fly ash was obtained from Jimah Energy Ventures Power Plant Negeri Sembilan. Cost aggregates of nominal size 20 mm was used in producing concrete and complied to BS 882 1996. River sand, which is fine aggregate, was used in this study and complied to BS 882 1996. Clean water was also added in the mixing concrete. Grade 25 concrete was produced using a water binder ratio of 0.55. 4 different mixes were used for this study according British standard. Mix design method of concrete. This 4 mix includes a control mix using OPC without or fly ash and other 3 mix with fly ash replacement, 10%, 20% and 30% by mass of OPC as in the control mix. The chemical composition of fly ash was conducted using X-ray fluorescence (XRF) at University Technology Malaysia. The particle size, shape and structure of fly ash was determined using scanning electron microscope (SEMs). The mix design of concrete was done according to British method of concrete mix design for grade 25. The slump test was used to evaluate the workability of the mix of concrete. Workability depends on water content, aggregate, which are shape and size distribution, and cementitious contents. Total of 48 cube samples were made according to BS 1881-116-1983. The compressive strength were determined by compressing the concrete cubes at 7, 14, 28, and 56 days using Matter's compression testing machine. The specimens were taken out of the curing tank and placed in open air about 2 hours before compress. For result and analysis, we will see based on chemical composition, microstructure with scanning electron micrograph SEM, workability and compressive strength. The chemical composition of cement and fly ash that used in this study was shown in the table 1. According to ASTM 61805, class F of fly ash state as silicon dioxide, aluminium oxide, and iron oxide is not less than 70%, and calcium oxide is less than 10%. Result from the table shows dose combination is 88% and can be classified as class F. Microstructure with scanning electron micrograph SEM in figure shows the SEM of the original fly ash from Jimah Venture Power Plant consists of mostly glassy and spherical particles. Size of particle fly ash, and the fly ash reacts with free lime in the existing of water and convert into calcium silicate hydrate, which is the strongest and durable portion of the concrete. According to the glassy and spherical particles may help to reduce internal friction between aggregates, thereby concrete containing fly ash, increase consistency and allow mobility for longer pumping distance. From the figure 1, they shows the semi-log graph of coarse aggregate sieve analysis, while in the figure 2 shows the semi-log graph of river sand analysis, and both from the result, both sample between coarse aggregate and river sand in all sizes within the limitation and comply to BS 882-1996. Generally, it's observed that percentage of fly ash in mixed concrete increase. Meanwhile, the workability of concrete decrease. Therefore, the increased replacement of cement with fly ash will be increased water demand in fresh concrete mix. The relationship between compressive strength and difference between percentage of fly ash at age 7 days, 14 days, 28 days, and 56 days shows in figure 3, while in table 3 shows the result of compressive strength of concrete with partial replacement of fly ash. The compressive strength of concrete also increased with age. The maximum compressive strength, 43.57 Nm², was seen at 10% replacement of OPC with fly ash at 56 days and exceed target mean strength, which is 38.12 Nm², but lower than control concrete. The increase in compressive strength at 56 days may be due to slow hydration process when increase of fly ash in concrete, which is slow reactive pozzolans, causes delay the hydration process at 28 days. In this study, fly ash was used as special replacement of OPC in different percentage of 0%, 10%, 20%, and 30%. From the XRF test shows calcium oxide is less than 10%, can we conclude that fly ash is class F and has a little cementitious properties. Thus, from the SEM, the shape of fly ash is spherical. The spherical shape of fly ash can reduce internal friction, thereby increasing the concrete consistency and allow mobility for longer pumping distance. Based on this study, the replacement of cement with fly ash significantly decreased the compressive strength of concrete. It is deduced that fly ash replacement of 10% of the weight of cement achieved the optimum value of compressive strength and considered the best ratio of cement replacement in a concrete mix at 56 days. From the slump test, the increase in fly ash content in concrete decreased the slump height, thus indicating that there is a decrease in the workability of concrete. Therefore, from the study, the partial replacement of cement by fly ash definitely more economical alternative and potential utilized in the field of construction industry with reducing environmental impact to surrounding. However, further study needs to be done on wide range of characteristics of concrete.